Hello friends, welcome to Learner's Planet. Friends, with this session, I'm starting a completely new series for the students who are appearing for CAT, XAT and other MBA entrance exams. Friends, I know in last few years, so many changes have taken place in CAT exam. Earlier, we used to have multiple choice questions only, but now we are having the questions that is TITA questions also, wherein we have to solve the questions completely and we have to write the answer, right? So for that you need to solve the complete questions completely, right? Earlier we used to have the approaches like elimination approach or backward approach that correct the questions through options. So many approaches were there, but now since TITA has been used, TITA has been started, now we just have to solve the questions completely. And apart from this pattern of questions, some style of asking of questions, some maybe some topics, they have also quite so many changes have taken place. Okay. So keeping all these things in mind, I am starting this completely new series in which for each and every topic, we will be looking at the concept builders. We will take the practice questions. I'll take the questions from previous year CAT papers and from various mock test papers and questions I will be taking. Then you can also send me doubts. I have already started getting doubts from the students, so I have now good collection of doubts as well. So we'll be taking each of them one by one, right? So in this beginning, in this first session of this topic, algebraic and logarithmic equalities, let's start it. Okay. Friends, as I was scanning the papers of last 3 years, 17, 18, 19 of CAT, every year at least two questions based on the topic inequalities are there. Either you have to find out the maximum value of a given expression or minimum value or integral solution based types of problem. So at least two questions are there. So I'll be taking 2-3 sessions of this topic. It's really going to be important. So I'm sure once we finish up this topic, you'll be definitely able to answer all these questions. Okay, so let's begin the class. And once again, I keep on reminding you, just note down the important points. Just pause the session whenever you feel like difficult, whenever you feel difficulty. Just replay the session because the recordings are available with you. So you can just replay the session, whatever part is you are not comfortable with. Okay, unless until you are clear with the concepts, you are clear with the question, do not move forward, right? See, generally my session length is 25 to 30 minutes, but an average or above average student, he or she takes at least 1 hour to complete that, right? Because sometimes you need to revise the things, sometimes you need to replay the concept, replay the portion of the recording. So it is ideal that you just, whenever you start studying with me, whenever you start watching the video, you just have at least 1 hour with you. Okay? So now let's begin this. Now, first of all, let us understand what exactly an inequality is, right? The very simple inequality, I just give an example. Suppose maybe x is greater than 2, right? So, see what is the difference between an inequality and an equation? Suppose I have x is equal to 2. That means we are having a fixed value, a unique value of x, right? But in case of inequality, there is not a unique solution, right? Suppose x is greater than 2, so you can have infinite values which are greater than 2, right? So x can take any values out of them, out of these infinite values. So this is an inequality, or we can say inequation, and this is an equation where you will get a unique solution. And in this case, infinite, more than one solutions we can say. Every time they may not be infinite, but we can say more than one solution. Depends upon the condition. Sometimes along with an inequality, some conditions are also given. So depends upon the condition, we can have one or more than one solution. But in case of equation, we always have just a unique solution, right? So this is the first difference between an inequation and equation. Now inequation can be of various types. Suppose x is greater than by a fixed quantity or a fixed expression, x is less than by a fixed quantity or a fixed expression, right? Greater than, equal to, or less than equal to. So there are precisely 4 types. greater than a, greater than equal to, less than, and less than equal to, right? And if it is greater than 0, that means the expression is positive. If it is less than 0, that means expression is negative. If it is greater than equal to 0, then the expression is non-negative. X is greater than equal to 0, that means non-negative. Or if it is x is less than equal to 0, then non-positive. So there is a difference between all of them. If you are told like x is positive, that means x has to be greater than 0. Okay. If we are told that x is non-negative, that means x can be even 0 also. Okay. But it cannot be less than 0. So x is greater than equal to 0. That is non-negative. This is positive. This is non-negative. For positive, x has to be greater than 0 only. For non-negative, x can be greater than equal to 0. Similarly, for negative, x has to be less than 0. And for non-positive, it can be 0 also. So x should be less than equal to 0. Right? So these are the very basic things for an inequality, for an inequation. Okay. Now let us understand what are the intervals. Okay, so as I've just explained you, x is greater than a, less than a, so there are different cases. So all the cases we can combine in just these 3 to 4 types of interval, right? So the first pattern is when x is lying between a and b. Okay, here you can see x is greater than a but less than b. So x is lying between a and b, right? And x is actually greater than a and less than b. So what exactly does it mean? X is greater than a. It is absolutely greater than a. It cannot be in any case equal to a. Similarly, it is less than b. In no case it will be equal to b. Right? That means the endpoints are not included. Now, whenever we are talking about inequalities, we are talking in real numbers only. Okay? Real numbers only we are talking about, not specifically integers or natural numbers. In particular questions, if the condition of a number being integer or natural number, if it is given, then it is a different matter. But if no conditions have been given, then you have to assume the variable to be a real number. Right? So we are talking about a real numbers range. So here, see, from a to b, suppose I tell you x is greater than 1 but less than 2. So how many numbers are there between 1 and 2? So most of the students will they will say this koi bhi number nahi hai beech mein, no numbers between them, right? Between 1 and 2. Right? But the thing is there are infinite numbers because we are talking in real number sense, right? So between 1 and 2 there are so many real numbers, infinite real numbers. Okay, you can say there are no integers between 1 and 2, but there are infinite real numbers between 1 and 2. So that is the first thing, right? So the endpoints, x is not equal to 1, x is not equal to 2, but x can take any value between 1 and 2, right? Because in no way we can show that x is what exactly the first value x can take, we cannot say, right? Immediately less than 1, immediately greater than 1 and immediately less than 2, that values x can take, but what that value will be, we don't know. Okay, so what we do, we present them in a style of bracket. So suppose x is between 1 and 2, we present them as x belongs to, that is belongs to sign, and 1 and 2. That means x can take any value between 1 and 2, but not 1, not 2. Not 1 and not 2, it cannot, x cannot take 1 or 2. For that to show, we use this round bracket. Round bracket means all the values from 1 to 2 are included except 1 and 2. Okay, so this is the first case. Second case is x is greater than equal to a and less than equal to b. That means x can take any values from a to b inclusive of a and b. Okay, that means in other words, if I say x is greater than equal to 1 and less than equal to 2, that means x can take any values from 1 to 2, all the infinite values inclusive of 1 and 2 both, right? So to represent this, we use this square bracket. So for this particular example, x belongs to 1 to 2, it can take all the values from 1 to 2 inclusive of 1 and 2. So there is a difference between this bracket and this bracket. In this bracket, x can take 1 and 2 as well. In this, if the data has been shown in this bracket, that means x cannot take the extreme values, that is 1 and 2 it cannot take. All the values between 1 and 2 it can take, but 1 and 2 no. Right? So this is closed interval, this is open interval. Okay, then what happens when from one side it is open and from other side it is closed? Then it's a combination of two bracket. On one side we will have the square bracket, and on other side we can have the round bracket. It can be like this or it can be like this. Both the cases can be there. So suppose I tell you x is greater than equal to 1 but less than 3. So we will use this bracket to show 1 and 3. For that we use this bracket. So this is a representation of this. X belong to 1 to 3. X can take all the values from 1 to 3 exclusive of 3 but inclusive of 1. Right? So this is one style, one more style. Then x is greater than 1 but less than equal to 3. That can be represented as 1, 2, 3. Now x can take all the values from 1 to 3 exclusive of 1 and inclusive of 3. So if we wish to include the value, the extreme value, we use the square bracket. If we don't wish to include the extreme value, we use this round bracket. Okay, so this is how we represent the intervals or the range of the applicable values or the favorable values. Okay. Now suppose we look at the infinite interval. Suppose you have been given that x is greater than a. That means x can take any values more than a, right? So that means it this is the way we present that. X cannot be a, but x is greater than a, and since this there is no limit to this, so the infinity is the next number, right? So x can take any values from a to infinity, but since infinity also we cannot count that, it is an undefined term, so we use this square, round bracket. So according to this, x is greater than a, x can take any values more than a, less than infinity, but neither a nor infinity. Okay, so this is how we represent that. If x is greater than equal to a, then x can take any values from a to infinity inclusive of a, right? If the other way is x is less than b, that means x can take any values from infinity, again it is not included, from minus infinity to b, but it cannot even take the value b because x is less than b, and in the last case it can take the value b as well, but negative infinity it cannot take, right? So this is how we represent the number or range and intervals. And obviously from minus infinity to infinity it is a complete series of real numbers, right? From minus infinity to infinity, this is the entire number line. Right? So these are the basic things which you should be knowing before we start discussing inequalities. Okay, so I hope this thing is clear to you. Now friends, the easiest method to solve the inequations is the wavy curve method. It is really very easy, very interesting, and once you are clear with this method, you can solve any inequality, right? So let's start some very basic, simplest inequalities. Gradually we will increase the level, right? Within just 5 minutes we will increase the level to solve the problems. Okay, so suppose you have maybe a very simple inequality. Suppose x minus 1, x plus 2, I want it to be greater than 0, right? There are two expressions. Whether the expressions are in numerator or in denominator, it really doesn't matter. Okay, so how do we draw the curve? First of all, what we have to find out, how this expression will be 0, will get 0 value, right? So if you put x is equal to 1 or x is equal to minus 2. So these are the zeros of the given expression. Okay, that is 1 and minus 2. Now what you have to do, you have to draw a number line and you have to draw these points on the number line. So this is minus 2, that is on the left hand side obviously in the number line, and 1 will be on the right hand side, right? Now you have to start the curve from rightmost side. The curve will come from infinity. Okay, we don't know the beginning point, but we are just taking it from infinity. So whenever there is a 0, just change the direction of the curve. Okay, again meet 0 and change the direction of the curve. Okay, so this is how we draw the curve. Okay, I'm not that neat in drawing the curve, but we just have to discuss the concept, that's it. We should be least bothered about the neatness of the curve, right? Now how would we judge, how would we say what are the favorable values for this expression, right? Now the curve, that is the portion of the curve that is below x-axis, below this number line, this is suppose x-axis or number line I can say. So this is the negative part, this is the positive part, and this is the positive part. That means if x takes any value more than 1, this is 1. If x takes any value more than 1, then this expression will be positive. Or if x takes any value less than minus 2, still this expression will be positive. You can randomly put up any values which are more than 1 or less than minus 2. You will get the expression to be positive, right? Suppose you take x is equal to maybe 3. So if you put 3 minus 1, that's a positive value, and 3 plus 2, that's also a positive value. Positive into positive, that will give you the positive value. Then in case you take x is less than minus 2, so suppose x you take minus 3, so this expression will be negative. Minus 3 minus 1, that is minus 4, and this expression, that is minus 3 plus 2, that is minus 1, still that be negative. Okay, so negative into negative will give you positive. Okay, so x can take any values more than 1 and less than minus 2, right? What you have to do, you just have to check the portion of the curve which is above the number line. Okay, so from there you can define the range. So x can take two values, two set of values. X belongs to minus infinity, because we don't know where this curve is going. So minus infinity to minus 2, union, along with that 1 to infinity. Now I'm using this round bracket because none of the values from minus infinity, minus 2, 1 and infinity are included, because we have been asked the inequality should be greater than 0. This expression should be greater than 0, right? If we use the square bracket, that means we are calculating the values which will make this expression to be 0 as well, right? This expression will be 0 if x is equal to 1 and x is equal to minus 2, because these are the zeros of this equation. Okay, but we don't want that, so I am eliminating these values by using this round bracket, right? So x can take any values from minus infinity to minus 2 or 1 to infinity. Now suppose we want this expression to be less than 0. Okay, then you have to choose the value of x from minus 2 to 1. X should be from minus 2 to 1. Again, I am not including any of them because we want it to be just less than 0. Okay, so this is simple. You can take any values from minus 2 to 1 and can check this expression will be less than 0. Suppose x you take as 0, that is a value between minus 2 to 1. So if x is equal to 0, then that means it is minus 1 into 2, so that is minus 2 and that is less than 0. So this is the very simple funda of wavy curve method. Okay, just note down the zeros of the expression on number line, then just start making the curve from right hand side, right topmost side, then change the direction of the curve from every 0. If there are 3 zeros, change the direction once again and again, no problem. Okay, now suppose we want this expression to be greater than equal to 0, right? In the previous case we just discussed greater than 0. Now suppose it has to be greater than equal to 0. So you don't have to do anything, you just have to change the style of the bracket, right? So it is from minus infinity to minus 2. Here we will include minus 2 but will not include minus infinity, as I've already told you. Infinity cannot be included. Union 1 to infinity. Here we will include 1 but will not include infinity. Right? Similarly, if we want this expression to be less than equal to 0, then from minus 2 to minus 1, both included. Okay, so it is the solution for this inequality, that is minus 2 to 1, and solution for this inequality when it is greater than 0, that is the solution. Now the questions in exams are not asked very simply. What will they ask? How many values, integral values x can take from minus 10 to 10? Right. Now you know this expression is less than equal to 0 when x is lying between minus 2 to 1. Now suppose you are asked how many integral values x can take. So how many integral values x can take? That is minus 2, minus 1, 0 and 1. So 4 integral values x can take when this expression x minus 1 and x plus 2 is less than equal to 0. So the questions are asked in this manner. Similarly, how many integral values between 5 to 10 x can take if this expression is greater than equal to 0? So since this expression will be positive if x is from 1 to infinity. So from 5 to 10 you can calculate the value 5, 6, 7, 8, 9, 10, 5 values, right? Or suppose you are asked whether x can take any value as 0 if we want this expression to be positive. No, because the numbers, that is the range, is minus infinity to minus 2 and from 1 to infinity. So between minus 2 to 1 the numbers are not favorable for this expression to be greater than equal to 0, right? So it is as simple as that. So I hope this very basic thing is clear to you. Okay. Now friends, these were the concept that I have just discussed, the wavy curve method, and we have taken a very simple example. But in exams there will be, so we can say much more difficulty level is expected. Okay, so the three important points I'm going to share with you, which you should take care while you are solving the inequality. Right, the first very important thing is there should not be any 0 in the denominator. So whatever the measures you have to take, okay, be careful on that. No negative in the square root, because we are discussing real numbers or real functions only. So there should not be any negative expression in the square root. Okay, we'll be taking the questions once we finish up this. So you'll be better clear with all these points at that time. Then the most important thing is the mistake which most of the students they do is that they do cross multiplication while they solve the inequality. Right? Suppose I give you maybe an example, 1 upon x is greater than 1. Right? So what they do is just blindly they do it this. And this is a blunder. I am just telling you this is a blunder. Don't do this. Never go for the cross multiplication when you are solving inequalities, right? Because what will happen, you will miss certain range, and what the range you will miss I will tell you once I solve this inequality. Okay, this is just a random example I'm taking over here, but still I will tell you what is the difference between this and if you do not go for the cross multiplication. Okay, so the three things are important. There should not be any 0 in the denominator, no negative in the square root, and no cross multiplication. These three are the thumb rules, you can say, for solving inequalities. Right? If any of them you miss out, you will end up making mistakes. Right? Now what is the answer? Suppose for that one student has done this, maybe 1 upon x is greater than 1, that means x has to be less than 1. Right? Now what is the portion he is missing? I'm not going to do the cross multiplication. So what I do is I just shift 1 over here. So 1 upon x minus 1 is greater than 0. That means 1 minus x upon x is greater than 0. So the next rule is, if you wish to change the sign of inequality, what you do, you multiply both the sides with negative, right? Then the sign of inequality will be changed. So it is x minus 1 upon x, it will be less than 0. Okay, just a moment. It is very simple thing that you must be knowing. If a is greater than 0, that minus a is less than 0, right? So this basic thing is there. So if 1 minus x upon x is greater than 0, that means x minus 1 upon x is less than 0. Okay, now the same thing we have to do. We are drawing a number line over here. Zeros of this expression is x is equal to 0, that is 0, and then x minus 1, the 0 is 1. Okay, so what is the answer to this inequality? That x can be from 0 to 1. And when we, just a moment, when we did the cross multiplication, what was our answer? X is less than 1. That means x is belongs to minus infinity to 1, right? So that was our answer, and our actual answer is this. You can see the difference. So what I told you, it's a blunder, right? X can be between 0 to 1 only if 1 upon x has to be greater than 1, right? It cannot take all the values less less than 1, right? Because if x is negative, 1 upon negative will not be greater than 1, right? 1 upon suppose minus 2, that is not greater than 1. So when the students, they go for the cross multiplication in case of inequalities, they just miss out that particular portion. Okay, so it is very important for you not to go for the cross multiplication in case when you are solving inequalities, and I have very clearly shown the example, right? So I hope now this thing is clear to you. Now when you are solving inequalities, what you should do, as in the previous example what I have done, here it was written 1 minus x, right? So in the numerator, what we have to do, we just have to rearrange the expression in such a manner that this variable should come first, right? So if it is 1 minus x, we should do it x minus 1, and while we are doing this, we have to change the sign of inequalities, because the concept I have already told you, if a is greater than b, that means minus a is less than minus b. It's a very simple thing. 3 is greater than 2, but minus 3 is less than minus 2, right? Similarly, the one more thing, that is maybe a is greater than 1, then 1 upon a will be less than 1, right? Similarly, just you can take example, 2 is greater than 1, but 1 upon 2 is less than 1, right? So these are very basic things you might have learnt in your junior classes. So I know I don't have to discuss it again and again, but it is just, I'm just trying to remind you, right? You have to be careful while you are solving inequalities. Okay, so we have taken very simple example. I have told you why should not you go for the cross multiplication in the solving inequalities. Now let's take some exact good examples. So this concept of inequalities, or the concept of the wavy curve method, will be better clearly in your mind. Now here in this question, we have to find out the largest possible set of real number which can be domain of this. That means we have to precisely find out the favorable values of x. Okay, so if we convert this to this, okay, x minus 1 upon x. Now since we have I have already told you, you need to keep certain things in your mind. So here we have the square root, here we have the expression in the denominator as well. Now I want this expression to be greater than 0, because the expression under the square root should be positive, right? So that means x minus 1, that means the expression under the square root should be positive. It can be 0 as well. So I can take this as to be greater than equal to 0, right? So the first thing is the expression under the square root should be positive, or we can say it should be non-negative. Precisely, non-negative is a correct word. So the expression under the square root should be non-negative. So I can say it is greater than equal to 0. Now the second thing that we have to consider is there should not be any 0 in the denominator, right? So what I do is I draw the number line. Zeros of this expression I will mark. Here it is 1, and in the denominator it is 0. Okay. Now, as I've already told you, it really doesn't matter when both the expression or any number of the expression, they are in the numerator or they are in the denominator. It really doesn't matter. Okay, you have to proceed the same way, because minus plus sign changes. It doesn't depend upon the expression whether it is in numerator or in denominator, right? So 0 of x minus 1 is 1, and 0 of x is 0, right? So the same way I'll be making the curve. So here it is positive, here it is positive, and here it is negative. But I want this expression to be positive, that means greater than equal to 0. So I have to choose the range from 1 to infinity and minus infinity to 0. So minus infinity to 0 union 1 to infinity. Okay. Now which type of bracket I have to use? Carefully you have to use the bracket. Okay. Minus infinity is never included, infinity is never included, right? If I use this 0, I want this expression to be greater than equal to 0, but if I include this 0, then what will happen? There will be a 0 in the denominator, which we don't want, right? There should not be any 0 in the denominator. So even if it is, we want this expression, we can have this expression to be 0, the entire expression, but for that we cannot make the denominator to be 0, so you have to exclude this. Okay, then 1, if you put x is equal to 1, we will be generating 0 in the numerator, so that is perfectly okay, so we can include 1. So this is the answer to this inequality, right? Precisely, this is the answer to this problem. So this is the other way of asking what are the favorable values of x, right? If fx is a real function, what are the favorable values of x? Or maybe you are asked how many integral values from 5 to 10 x can take, or from a particular range you may be asked in how many values x can take, right? So from minus infinity to 0 union 1 to infinity, only 1 is included, remaining all 3 they are not included. So this is the largest interval, or this is the largest set of values that x can take. Okay, so I hope this simple thing is clear to you. Let's take another example. Now x minus 4, x plus 3, x plus 4, x plus 5 to be greater than 0. So the very first step what you will do is draw the number line. Mark the zeros. So here it is 4, then it is minus 3, then minus 4, then minus 5, right? So start the curve, change the direction, change the direction, change the direction. We want this expression to be greater than 0, so we have this range, and this range. So it is minus infinity to minus 5. I'm not putting the bracket. We will look at the question, then we'll put the bracket. Then union minus 4 to minus 3, then union 4 to infinity. Now there should not be any 0 in the denominator, so just keeping that thing in mind, we need to put up the, in fact this entire expression is greater than 0, that is no equal to 0 wala concept over here, so all this bracket will be this only. If it is equal to 0, then we at the 3 points at the 2 points 4 and minus 3, we just have to change the style of the bracket, that is a square bracket. But in this case we want this expression to be just greater than 0. Okay, so here it is minus infinity to minus 5. So here if we look at the option, this is the correct answer because they have missed out this range, this particular expression. So doesn't matter, since we have been given the option, we can choose the correct one, right, which is favorable to us. So in this option we have this favorable part. Okay, so I hope this thing is clear to you. Now let's take this question. Find the largest integer x for which this expression, that is x minus 2 upon x square minus 9 is less than 0. So first of all, what you have to do, you just have to factorize this. So it is x minus 2, x minus 3, x plus 3, and we want it to be greater than less than 0. Mark the zeros, 2, 3 and minus 3. Okay, so we want this expression to be less than 0. So from minus infinity to minus 3, union 2 to 3. So we want the largest integer for which this expression to be greater than 0. Now we can say from 2 to 3 this expression will be positive, less than 0. But the problem is from 2 to 3 neither 2 nor 3 can be included, and between 2 and 3 there is no integer. So integer we have to take from this range. right? So minus 3 cannot be included, and immediately smaller than minus 3, the largest integer is minus 4. So the answer to this problem is minus 4. So minus 4 is the largest integer for which this expression will be less than 0. So this is a TITA type question. Okay, so I hope this thing is clear to you. X minus 2, x minus 3, x plus 3 less than 0. We put up the zeros 2, 3, minus 3 in the same order as a number line. Then just make the curve from minus infinity to minus 3 and from 3 to infinity, from 2 to 3. This expression will be negative, the portion that is below the number line. But from 2 to 3 we don't have any integer, and so the largest integer that we have is just immediately smaller than minus 3, that is minus 4, right? I hope this thing is clear. Now what is the minimum value of x if y is positive? It is also given that x is an integer. Okay, so that means we want this expression to be greater than 0, right? Because this is y and y has to be positive. So what you have to do, you just have to factorize this. So it is x minus 5 upon 7 into 2 is 14. So that is x plus 7 and x minus 2. Okay, so here it is 2, then 5, then minus 7. We want this expression to be greater than 0. So this is the range. This is the range. Now, since we have to find out the minimum value of x, so below minus 7, this expression will be negative, right? And we want this expression to be positive. So we cannot even take minus 7, because if x is equal to minus 7, then this expression will be in fact undefined. In the denominator there will be a 0 generated, right? So between 2 to minus 7 we have the minimum value as minus 6. Okay, from minus 6 to 3, these are the other values, but which will make this expression to be positive. But since we have been asked the minimum value, so the smallest value will be minus 6. Okay, so when x is equal to minus 6, this expression will be positive. That is the smallest value x can take. Okay, smallest value of x is minus 6, which will make this expression to be positive. So clear? Now this question we have already done. Now this is a new pattern. Here we have been given the power of expression as well. So friends, suppose I have an expression maybe x minus 3 whole square. I wanted this to be greater than 0. Now since this is a square expression, it will always be greater than 0, right? So while solving inequalities, you can skip these parts, right? So in this particular inequalities, you can skip these two portions because they are perfect squares. So they will not make any sort of impact while solving in the solution of this inequality, right? If x is negative or positive, this expression will always be positive. If x is negative or positive, or maybe less than minus 4, greater than minus 4, this expression will always be positive. Similarly, in this case, x is greater than minus 3, less than minus 3, whatever x value of x is there, this expression will always be positive, right? So we'll skip these two portions. Okay, now this is x plus 1, x minus 5n. So this is 2, this is 5, and this is minus 1. Okay, so what is the maximum value of x if y is negative? So we want this expression to be less than 0, right? So it will be less than 0 from minus infinity to minus 1 union 2 to 5. So maximum value we will get from this, right? It cannot take 5 because at 5 this expression will be 0, right? But we want it to be less than 0. So immediately less than 5, the largest value is 4, right? So if x is equal to 4, this expression will be negative. Okay, that is the maximum value x can take when y is less than 0. So I hope this thing is clear to you now. Now let's solve this. Here x minus 1, 3 minus x, x minus 2 whole square is greater than 0. So skip this portion, right? Now we have to solve x minus 1 into 3 minus x to be greater than 0. So the very first step, I will rearrange this. So it is x minus 1, x minus 3, and since I have multiplied this side by negative, so the sign of inequality will be changed. Okay, after that the story is very simple, 1, 3. So x should be any value from 1 to 3. If we want this expression to be less than 0, so I will include neither 1 nor 3. Okay, so that thing is clear to you. We can take very simple, so many examples, but okay, just one. So here in this case 3 upon x minus 2 is less than 1, right? So what I will do, first of all, we will shift this 1 to that side. So 3 upon x minus 2 minus 1 should be less than 0. Now go for LCM. 3 minus x plus 2 upon x minus 2 is less than 0. As I've already told you, don't go for the cross multiplication. Now this is 3 plus 2, that is 5 minus x upon x minus 2 to be less than 0. That means x minus 5 upon x minus 2 should be greater than 0. So minus infinity to 2 and 5 to infinity. So that is the answer to this problem. Okay. One more. Now here we are having the less than equal to sign. So we need to change the style of the bracket. That's why I'm taking this question. So the very first thing is minus 2 less than equal to 0. Take LCM. 1 minus 2x, okay, plus 2 by x minus 1 should be less than equal to 0. So here 3 minus 2x upon x minus 1 to be less than equal to 0. Change the sign. It should be greater than equal to 0. So here it is 1 and 2x minus 3 is 0. So it is 3 by 2. Okay. So x should be from 1 to 3 by 2. Now what we can include? 3 by 2 can be included because that will generate the 0 in the numerator. So I will include this. But 1 cannot be included because that will generate a 0 in the denominator. So this is the answer. Right. So I hope this thing is simple. Now you can do enough practice. You can have the questions. Any doubts if you have, you can definitely reach me. Right. Now let's try this problem. In this particular problem, I'm talking about this. We need to club two solutions. Okay, because y is root of x minus 1 and y is the combination of root of x minus 1 and 6 minus x, right? So we will solve them individually, then we will club the solution. Okay, so as I've told you, the level of difficulty will increase gradually. So till now we have just done the simple questions. Now we'll take the questions of bit higher level. So here the expression should be under the square root should be non-negative. So x minus 1 should be greater than equal to 0. So the solution is very simple. It should be 1 to infinity, this one, right? Here 6 minus x should be greater than 0, greater than equal to 0. That means x minus 6 should be less than equal to 0. That means x belongs to minus infinity to 6. Okay, now we have to club these two solutions because x can take any value from 1 to infinity also, x can take any value from minus infinity to 6. But since y is the combination of these two expressions, we have to select the values of x which are favorable for both of them. Right, suppose I select 7. Suppose I take x as 7. Because from this expression x can be any value from 1 to infinity. So suppose I take x as 7. So this will be positive but this will turn negative, right? So that will be a negative under the square root. So that is not the favorable value. And similarly if we have maybe any value, say maybe minus 2, right? So that is there in this range, right? But if I put x is equal to minus 2, this expression will be negative, right? So we have to choose a range which satisfy both these expression. Okay, so what we have to do, the very simple thing I'm asking you to do is just note down the range over here. So here it is, just note down all the things. This is minus infinity, this is 1, this is 6 and this is infinity. Okay, now what you do, just a moment. Mark both the ranges over here. So 1 to infinity, this is the range. Okay. So for this expression, this is the answer. And for this expression, I'll take the other color, maybe this. So here it is minus infinity to 6. So here it is minus infinity to 6. Now you just have to choose the answer which satisfy both of them. That means the portion that is covered by this red line also and this blue line also. So that is this portion. Getting me? From 1 to 6. So x can take any value from 1 to 6. Okay. Both inclusive. X can take any value from 1 to 6. Now how many integers are there which integral values x can take? That is 1, 2, 3, 4, 5, 6, 6 values. Right? So when you are having the combination of two, maybe they are added or subtracted, you just have to consider both of them and you have to find out the common solution. When we'll be doing lot many questions, so all these concepts will be clear in your mind. Okay. Now friends, let's finish up this session, and in the next session we'll be taking more problems and gradually the level of the problems will be increased. Okay, and in next two session I'll take you to the exact CAT level where we'll be solving the questions from previous year CAT papers, all the mock tests and everything, right? So whatever the doubts you are having, you can definitely send them to me. The mail ID of mine has been written in the description. You can note that down. You can follow us on our Facebook page. You can join my Facebook group, that in Mission 2020. All the links have already been given over there. And since we have started the paid membership, so all the videos which I am putting on YouTube now, they will be chargeable for after 2 days, right? So for all the videos you can watch for 48 hours for free. After 2 days all the videos will be converted to paid videos, right? For that you can definitely subscribe or you can join my channel, right? The prices are really reasonable. I have already told you why I am making these videos to be paid. So I hope you will cooperate with me and you will definitely support me in this mission. Okay, so wish you luck. I'll see you in the next session once again. Bye bye.